today's lesson is going to be on two important formulas that we are going to use over and over again in geometry. And those two formulas are the midpoint and distance formulas. So the first formula that we're going to talk about is the midpoint formula. And for all of these formulas, we're talking about line segments that happen to be on a coordinate plane. So here, if we have segment AB on a coordinate plane and its endpoints are x1, y1, and x2, y2, then the coordinates of the midpoint is going to be the average of each of those coordinates, okay? So in other words, we would take x1 plus x2 and divide that by 2, and that would be the x coordinate of our midpoint. And then the y coordinate of our midpoint would be y1 plus y2 over 2, okay? So we're taking the average of your x coordinates and your y coordinates to find the coordinates of the midpoint, okay? So let's just practice that. So for the first 4 problems, it gives us the coordinates of our endpoints A and B, and we want to find the coordinates of the midpoint M, okay? So in our first segment, all right, I'm going to label each of these x1, y1, and x2, y2. Okay, that's going to be especially important when we do the distance formula, so I just want to get in the habit of doing that now. So if I wanted to find the coordinates of my midpoint, for my x coordinates, I have 3, 3, and 7. So I'm going to take 3 plus 7 and divide that by 2. And then I'm going to look at my y coordinates. So I have 5 and 3. So I take 5 plus 3 and divide by 2. And when I simplify that, I'm going to have 10 over 2 and 8 over 2. So the coordinates of this midpoint M, all right, 10 over 2 is 5 and 8 over 2 is 4. Okay, so this would be the midpoint of this segment AB here. Okay. For number 2, I'm going to do the same thing. All right, so again, I'm looking at here my x's are -8 and 2. So -8 plus 2 divided by 2. And my y coordinates are 5 and 7. So I'm going to take 5 plus 7 and divide by 2. Okay, so as I simplify, I'm going to have -6 over 2, 12 over 2, and the coordinates of that midpoint M are going to be -3, 6. Okay? All right, so this works when you have negative coordinates. It's the same idea. All right, if I take a look at number 3, all right, again, I'm going to just label those coordinates. All right, so here I'm going to have 6 plus -3, all right, which is really just 6 minus 3, but I'm going to write it this way just to kind of keep in the habit of what that formula is, over 2, and then -1 plus -13 over 2, okay? Again, you could just put -1 minus 13 if you wanted. It's the same thing, okay? So here I have 3 over 2 and -14 over 2. Now, when I do these, I prefer my students to write these as decimals instead of as improper fractions. So I'm going to change 3 over 2 to 1.5. And -14 over 2 is going to simplify to -7. All right, so this would be the coordinate of my midpoints. All right, and we'll try one more. All right, so again, I'm just going to label those points. Okay, so I have -7, and then here I'm just going to do -3 over 2 to show you that you will get the right answer either way. So I take the average of my x's, the average of my y's. I'm going to simplify that a little bit. All right, and again, it's up to your teacher if, They want you to leave that as 1/2 or make it a decimal. Okay, so those are some 4 basic, just finding the midpoints of a segment on a coordinate plane. Okay. Now it gets a little bit more complicated in these next sets of questions. So over here it says M is the midpoint of segment AB. Given the coordinates of midpoint M and endpoint A, we want to find the coordinates of the other endpoint B. Okay, so here, if I just kind of sketch this out really quick, right? I know that A is 2, 1, let's say that's here. I know M is like 4, 6, let's say that's here. So B is probably going to be somewhere over here. And we just want to find the coordinates of that other endpoint. Okay? So that's what we're trying to do here. We're not trying to find the midpoint. We're trying to find another endpoint. All right? So I like to think of this as 2 separate problems. Okay? So first, I'm going to try to find the x value. Okay? So if I look at my midpoint formula, all right, I know that 2 plus my other endpoint, I don't know what that other endpoint is, right? So B is some coordinate x comma y that we're trying to find. All right, so 2 plus whatever x is, when I divide that by 2, I'm going to get 4 as my answer, okay? So I know what the ending result is going to be. All right, so 2 plus whatever this coordinate x is, the average of that is 4. All right, so if I wanted to try to solve for x, the first thing I'm going to do here is multiply both sides by 2. All right, so I'm going to have 2 plus x equals 8, and x is going to equal 6. Okay, so I found the x coordinate of B. Now I want to find the y coordinate, or I want to find my y value. Okay, so 1 plus whatever this y value is divided by 2 is going to equal that midpoint value of 6. All right, so again, I'm going to multiply both sides by 2, and I have 1 plus y equals 12, or y equals 11. Okay, so I know the coordinates of B is 6, 11. All right, so that's how we kind of work these problems when we're given an endpoint and the midpoint, and we want to find the other endpoint. All right, so let's try some other examples. All right, for number 6, all right, I always like to break this up into trying to find my x and trying to find my y value. And I do think it helps, especially when you're starting off, just to kind of write that B is x comma y. All right, so you don't forget how to set these up. All right, so we're gonna have 5 plus x divided by 2, and the answer is gonna be 1. All right, multiply both sides by 2, so 5 plus x equals 2. All right, and here I'm gonna get x equals -3. All right, for my y value, I have 1 plus y divided by 2 equals 4. So 1 plus y equals 8, and y equals 7. So the coordinates of B are going to be -3, 7. All right, moving along, I have my x value, my y value. All right, so -7 plus x divided by 2 is going to be 2. All right, so my x coordinate here is 11. For my y values, I have 11 plus some value y divided by 2 is going to equal 1. All right, so 11 plus y equals 2, and y equals -9. So the coordinate of B is 11, -9. Okay. And for our last one, again, looking for the the x value first, and then our y value. All right, so my x value, I have 4 plus x divided by 2 equals -3. All right, you do want to be careful with your negatives. Always use that calculator if you're struggling with adding, subtracting, and dealing with negative numbers. And then for our y value, we have -8 plus x over 2 is going to equal 2. So -8 plus x equals 4. And oops, I'm saying this is x, and I should really be writing this as y. We get y equals 12. All right, so coordinate B is going to be -10, 12. All right, and those are our examples of being given an endpoint and a midpoint and trying to find the other endpoint. Okay. All right, so that's pretty much the two kind of questions that you would get asked with midpoint formula on a coordinate plane. Okay, so now we're going to get into the distance formula. All right, so the distance formula is, again, if we have those 2 points on a coordinate plane, A and B, and the coordinates are x1, y1, and x2, y2. All right, we want to find the distance between those 2 points, or the length of that line segment. Okay, now I want to show you, I think that the distance formula is a little bit complicated, and I think if I just show it to you, it's going to seem like it's really hard to remember. All right, but the distance formula is nothing more than the Pythagorean theorem. Okay, so I have these red lines here, okay, that kind of show you that I am creating a right triangle here, okay? And if I wanted to find the length of my hypotenuse, if I wanted to do that for this right triangle, I would use my Pythagorean theorem, right? So c squared equals a squared plus b squared. Okay, we can do the same idea here. Okay, so AB, that distance that we're trying to find, okay, AB squared is going to be equal to, all right, if we take this side here, all right, this coordinate here that makes this a right triangle is going to be x2 comma y1. So that x value is the x2, my y value is that y1 value. Okay, so this distance here, all right, is going to be that length x2 minus x1. Okay, and it's going to be the absolute value of that because distance is always positive. If I wanted to find the distance between these 2 points here, all right, or that second leg of my right triangle, all right, it would be the value of y2 minus y1, all right, and that the absolute value of that because it's positive. So if I kind of tie this into the Pythagorean theorem, all right, this AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay? All right, so this is nothing more than the Pythagorean theorem. If I wanted to solve this, so I'm just finding the length of AB and I'm not finding the length of AB squared, then AB is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and this right here is your distance formula. Okay, so it looks a little bit overwhelming at first when you first see it, all right, but if you realize it's really nothing more than the distance formula, or I'm sorry, it's nothing more than the Pythagorean theorem, all right, which is something that you should have already seen before, it doesn't seem so bad, okay? All right, so let's try this out. This is where we definitely do want to make sure that we label our coordinates. Okay, so I'm going to label my x1, y1, x2, y2. And it's really important here that we don't mix these up, that our first coordinate has our little subscripts of 1s and our second has the 2s. Okay, so if I wanted to find the length of A, B, it's going to be the square root, all right, of, and I'm just going to use this formula where I see x2, I'm plugging in x2. Okay, so 5 minus 1 squared plus 4 minus 2 squared. All right, now to simplify this, I'm going to do what's in my parentheses first. So 5 minus 1, it's going to be 4 squared. 4 minus 2 is 2 squared. All right, then I'm going to do my exponents. All right, so 4 squared is 16. 2 squared is 4. Okay, add my two numbers together, and I have the square root of 20. Now you can either plug this into your calculator and get a decimal if you know how to simplify radicals. All right, when I simplify my radical, this is going to be 2 root 5. If you just plug it into your calculator and get a decimal answer, all right, it's going to be 4.47. Okay, so it depends on your teacher how your answers are supposed to be written, either in a radical form, a simplified radical form, or in a decimal. Okay, so these do take a lot of practice. All right, there's a lot of room for error in these problems. All right, so we want to take these slow. So if I wanted to find the distance between points R and S here, all right, I'm going to take the square roots. All right, so I have 5 minus -8 squared. Okay, so that's going to become a plus 1 minus 7 squared. All right, and when we're simplifying this, we want to do this slowly. We don't want to go and try to simplify too much at once, okay, because that's where we're going to make mistakes. Okay, so 13 squared is going to be 169. If you are plugging -6 squared into your calculator, please make sure that you have parentheses around the -6. Otherwise, your calculator is going to give you the wrong answer. So this should be a plus 36. And we're going to have the square root of 205. That can't be simplified. All right, so the square root of 205, or if we're using decimals, it's going to be about 14.32. All right, moving along. All right, again, it is definitely worth it to take your time to label these coordinates. All right, so if I wanted to find the length of LM, I have x2 minus x1, so that's minus a negative, that becomes positive, squared, plus 3 minus 5 squared. 2 plus 3 is 5 squared, plus -2 squared. All right, and as we simplify, we're going to get 25 plus 4 to get the square root of 29, which is approximately 5.39. All right, so we'll do a couple more examples. If you want to pause the video at this point and try these on your own and then check along, all right, you can. All right, otherwise, we're just going to keep going. -6 minus -9 is going to be plus 9 squared plus 5 minus 9 squared. All right, these kind of get a little tedious when we do them over and over again, but the distance formula is really important in geometry. It's one of those things you want to make sure you can practice. So for number 12, we get a nice perfect square. and we just get xy equals 5. Okay. All right, and then 2 more problems. All right, the length of GH, we have -4 minus 0 squared plus -6 minus 5 squared. All right, 16 plus 121, we get the square root of 137. That can't be simplified. So the square root of 137 is approximately 11.7 if we have a decimal answer. All right, and then our last one here, we're trying to find the length of PQ. All right, so again, 0 minus 3 squared plus our y2 minus y1, so 2 minus 8 squared. Simplify what's inside your parentheses. All right, simplify those exponents. All right, here we have this square root of 45, which can be simplified. So if I were to simplify my radicals, that would be the square root of 9 times the square root of 5, which is 3 root 5. Or as a decimal, it's going to be 6.71. Okay? And that is it for the distance formula. If you have any questions, you can comment below. All right, otherwise, thanks so much for watching.